Hello everyone, welcome back to my channel Physixopedia. Thanks for watching my videos. Please subscribe to my channel. Leave your comments in the comment box. Please share to your friends. So in previous lecture we have started discussing about doppler effect. In previous lecture we have discussed when an observer is at rest and the source is approaching to the observer, what is the effective frequency or what is the apparent frequency that an observer observes. Why he observed different intensities of the sound when the source is moving towards to the observer and when source is moving away from the observer with the formula. Now we are going to see another case. An apparent frequency when the observer moves towards the source. Now here the source is at rest, observer is moving towards to the source. What is the apparent frequency that he is going to observe? Let us look about. Here is the source which is at rest, which is producing a constant sound waves towards. So here is the observer. Here is the source. Let me call it as A. The source is not moving, which is at rest, but observer is moving towards to the source with a velocity v0. I'll consider velocity of the observer is v0. Okay. So here you clearly observe the sound produced by the source is at constant regular interval of times. Let me say the time taken between the time gap between the two waves T0 is equals to 1 by lambda. So 1 by frequency, not lambda. This is what the time gap between the two waves. So now what happens? Listen carefully. When the observer received a first wave, let the time starts now. When the observer received the first wave, now the time is started. So what is the time gap between the two waves, which is nothing but T0? What is the velocity the sound is traveling? Let this be V. V is the velocity of the sound. So what is the distance between two sounds then? The second sound may be over somewhere here. The distance between these two sound waves will be velocity of the sound into T0. Right? Because the time gap between the two sound waves are T0, therefore, and the velocity of the sound is V. Therefore, when the first sound is reached, when the second sound is going to reach him, the distance between the first sound wave and second sound wave will be V into T0. Right? This is how the sound waves are going to reach him. Right? So, the distance between the second sound and the observer is V0. This is the length. Let me consider it as some x. The distance between the second sound and the observer. In what time this sound wave will going to reach the observer? In what time? Here you observe, if the observer is at rest, the second sound wave also is going to reach him in the time T0 only. But here, the observer is moving towards to the sound wave, even the sound is moving towards to the observer. Therefore, the time taken by the observer to receive the sound will be lesser than T0. Right? So, let me call that as some T dash. T dash is lesser than T0. Remember this point. So what to write? So what is the velocity of the sound with respect to observer? Velocity of the sound with respect to observer is equals to velocity of sound minus velocity of the observer. Right? Velocity of the sound minus velocity of the observer. What you can write this as? Velocity of the sound is V towards positive. Velocity of observer is minus V0. So velocity of the sound with respect to observer is equals to V plus V0. What is the distance between the second sound wave and the observer? V T naught. Therefore, what is the time taken now? So I can write this as the new time taken T dash is equals to V T naught. This is what the distance between the two sound waves by relative velocity between them, V plus V naught. Right? So what I am going to get it then? So the new time or apparent time taken by the second sound wave to reach the observer T dash is equals to V T naught by V plus V naught. So what I can write it as frequency now? T naught is equals to frequency, T dash is equals to 1 by effective frequency or apparent frequency. I will write it as apparent frequency is equals to V plus V naught by V into 1 by T naught. So apparent frequency can be written as V plus V naught by V into the real frequency. I hope you understand, right? If the observer is moving away from the source, then what will be the answer? If the observer is moving away from the source, the apparent frequency will be V minus V naught by V into real frequency. If the source is at rest, observer is approaching the source, then the apparent frequency the observer observes is F dash is equal to V plus V naught by V into F, where F is the real frequency of the sound, V is the velocity of the sound, V naught is the velocity of the observer. And if the observer is moving away from the source, then apparent frequency is equal to V minus V naught by V into real frequency. I hope you understand the apparent frequency observed when the observer is moving towards to the source and moving away from the source when the source is at rest. So this is what the apparent frequency formula is in the Doppler effect. I hope you understand this lecture. If you like this, please like the button, share to your friends, leave your comments in the comment box. Please don't forget to subscribe to my channel. Thank you.